Hello all, welcome back to EduMoon tutorials. In this video, as the continuation of the previous topic, we will be discussing about the Greebeck normal form, which is also called as GNF. So a grammar is said to be in GNF if all the productions of the grammar in the form of A tends to A alpha, where this alpha belongs to V star. That is, every production rule should be in the form of, that is, not terminal will be producing a terminal first and then followed by any number of variables because it is given as V star. So also you can also remember this one as V equal to T V star, where V is variable, that is non-terminal, and T is a terminal. So there can be any number of terminals here, either it is 0 or 1 or 2 and so on. So now this grammar can be converted into its equivalent to GNF form by using two lemmas. So here we discuss about that lemma first. So the first lemma is called as substitution lemma. So here assume that there is a grammar with productions A tends to alpha 1, B alpha 2. And the productions of B are, the variable B are beta 1, beta 2 and so on up to beta n terms. So these production rules in the grammar can be overwritten as, so just by substituting B equal to beta 1 for the first time, next beta 2 and so on up to the n values. So the production will be A tends to alpha 1, beta 1, alpha 2. So we substituted the first beta, next alpha 1, beta 2, alpha 2 and so on. If you substituted all the n values, it will be alpha 1, beta n, alpha 2. So here we simply eliminated one variable called b, which is available in the original grammar. In the equivalent grammar, you can see there is only one variable that is producing the n production rules. So that is giving the n production rules. So this is the first lemma that is using, which is called as substitution lemma. The second lemma we call it as, the second lemma is, we call it that one as elimination of left recursion. So here we use this lemma to eliminate the left recursion. So first of all, we see what is a left recursion grammar. So for example, a grammar is given as A tends to A alpha 1 or A alpha 2 and so on up to A alpha n terms. And again A tends to beta 1 or beta 2 so on up to some beta s terms are there. So this is called as left recursion. You can see that on the right hand side of the production rule, it starts with the same non-terminal which is producing that. So when you register the derivation tree, so it follows like this one where the A is producing the same variable A for infinite number of times, so on until it halts with some beta value. So this is called as left recursion. So to eliminate this one, these production rules are overwritten as, again we just remove the left recursion here, that is by writing the production rules as A is equal to beta I or A is equal to beta ib. So we introduce a new variable called b here. So now what is the value of I here is, so beta 1, beta 2 so on up to s times. So the value of I goes from 1 to s here. So no matter how many betas are there, we are going to substitute the value here with beta I and beta ib. So we introduce a new variable called b. So the productions of b will be equal to alpha I and b will be equal to alpha ib. So again here the value of I goes from 1 to n, because assume that we are having n values for alpha and s values for beta. So here the value of b goes from I goes from 1 to s for betas, and here the value of I goes from 1 to n for the alpha. So these are its equivalent production rules after removing the left recursion. So the same string can be generated using the same grammar here. Whatever the string is generated by this grammar will also be generated by this grammar rule productions. So using these two lemmas, we are going to convert a given grammar, that is CFG, into its equivalent Greebeck normal form. So let us discuss that with an example problem. So assuming this is the given grammar and we need to convert that into the Greebeck normal form. So the grammar you can see that which is in already in CNF. So every non-terminal is producing two non-terminals or else a single terminal here. So actually this grammar is in GNF form. So now we try to convert that into a GNF. So that is in CNF actually. We are going to convert that into a GNF form. So for example, if you want to convert that A1 into GNF, it should start with terminal. So which is here A2 here. So if A2 the productions of A2, if the A2 productions are in GNF, so you can substitute them here. So it will be in GNF. And to get A2 productions into GNF, you can see the starting variable here is A3. So if A3 are in GNF, you can substitute them here and so on. So you can see the tree structure here. A1 is producing A2 and A3, and again A2 is producing A1, A3 and A1, and again A3 is producing A1. So this is an indirect recursion again goes on here. We try to convert this grammar into its equivalent GNF production by using those two lemmas as follows. So first of all, we substitute the value of A1 in A3 here because the starting variable here is A1. So we substitute the A1 production in A3. So the A3 production will be, so using the first lemma that is substitution lemma, just you substitute that A1 equal to A2 A3 and also we had A2 here by A. So this is the result of substituting A1 here. So again the starting variable here is A2. So again we substitute A2 in A3 now. So A3 production should be equal to, so now A3 has two productions, you can see that A3 has two production rules. So we substitute this one first and this one next. So we get two more production rules here. So after using that, the production rules will be A3 will be equal to A3 A1 and we get the remaining that is A3 A2, or we substitute the next one that is B. So this will be A3 A2. So we substituted these two rules for A2 here. So we get 2 and still this is left out. So we write A here. So now you can see that the production rules of A3, these two are actually in GNF because they are starting with terminal followed by any number of variables. And now this is A3 here, that is nothing but a left recursion. Now you can see that there is an occurrence of left recursion here. So to eliminate this left recursion, what we do is we use lemma 2. So using lemma 2 now, we just eliminate the left recursion here. So what will be this one? This is in the form of, you can see here, A tends to A alpha. So assume that this is A tends to A alpha and beta 1 beta 2. So this is actually in the form of that. So you can just apply that lemma 2 here. So this is in the form of, just we are writing for understanding purpose. A tends to, this is in the form of A, and this entire thing is alpha 1, and this is beta 1 and beta 2. So we can see that the value of n, previously it is alpha 1, alpha 2, so on up to n values. So we have only one alpha and two beta values. So after substituting this lemma 2 here, so what are the productions of A3 here? The A3 productions will be A3 will be equal to beta I and B. So beta I and beta I B. So betas, we have two betas here, so this will be B A3 A2, and here this is beta I, and beta I B means we have to do the same thing with new variable. So here we write B A3 A2, and the new variable let me call it as B3. I can name it as B or B3 whatever, and A B3. So this is, these two are beta I and this is beta IB. So since we included that new variable, so that we also write for B3. So B3 is equal to, so according to the lemma, the B3 productions are equal to alpha A and alpha AB. So what is alpha here? This is the alpha. So that is A1, A3, A2, and alpha IB means A1, A3, A2, B3. So these are the respective productions of A3 and B3 after applying the lemma 2. So now you can observe that all the productions of A3 are in GNF because you can see that all the productions of A3 are starting with a terminal here and followed by a number of variables. So now we can consider that all the production rules are in GNF. So now A3 are in GNF, we can just substitute that A3, substitute A3 in, therefore we can substitute A3 in A2 because you can see the A2 starting variable is A3. So all the productions of A3 will also, A2 will also be in GNF after substituting. So just after substituting A3 in A2, the A2 productions will be like, just add A1 at the end. You can see this production rule here. Just adding A1 at the end of these productions. So A2 will be B A3 A2 A1 A A1 B A3 A2 B3 A1 and A B3 A1. So this is actually B3 here. Right. So now after substituting A3 and A2, you can see all the productions of A2 are also in GNF now because everything is starting with a terminal. So we just substitute now A3 in, sorry, A2 in A1 so that these productions are also in GNF. So just substituting now since A2 are in GNF, substitute A2 in A1. So the A1 productions will be like, so now you can get the A1 production as A1 is equal to, just substitute this, just add that last bit A3 to all the A2 productions. So here it will be B A3 A2 A1 A2, sorry A3 or A1 A3 or B A3 A2 B3 A1 A3 or A B3 A1 A3. So these are the production rules for A1. And now you can see that all the A1 productions are in GNF. So you can see all of them are starting with a terminal here. So now we can substitute A1 because still B3 is left out. So B3 is also part of the grammar and it is starting with A1. So these two productions just substitute all A1. So now substituting A1 in B3, we get all the B3 productions are also into GNF. So the B3 productions will be just substituting these all these production rules in this one. So we write B A3 A2 A1 A3 A3 A2. So that's the first one. We substitute this entire thing in this one. So again we write the same thing, that is A A1 A3 A3 A2. Next one and so on. We substitute the remaining also. B A3 A2 B3 A1 A3 A3 A2 and finally A B3 A1 A3 A3 A2. So this is the first thing, we substitute all the A1 productions in this part of the equation and also we substitute here. So again this will continue like B A3 A2 A1 A3 A3 A2 B3 or A1 A3 A3 A2 B3 and finally B A3 A2 B3 A1 A3 A3 A2 B3. The last one is A B3 A1 A3 A3 A2 B3. So this is how we convert the equivalent grammar into its GNF form. So the production rules which are in the finally GNF are, we need to write the productions of A3, A1, A2 and also, so these are the production rules which are in GNF. So finally we need to write again all these, the productions of A2, A1 and A3 and also for B3. So these are the production rules which are in GNF. So the entire productions of V3 as well. So these are the production rules which are in GNF. So this is how we convert a given grammar into its equivalent GNF form. So the only simple thing is just we substitute using the lemma 1 until we get the left recursion, and when we try to remove the left recursion we get all the production rules of that particular variable into its GNF form. Then we can substitute that into the other variables where it is in the starting of the right hand side production rule. So this is how we continued for the GNF. So in the next video we shall be looking at the concept called as Turing machines, which is very important in the entire concept of LAT. So let us discuss about this in the next video. Thank you all.